In this video lesson, we will be writing and solving inequalities. I've included our state standards. We have 610A as our readiness standard, where we have to model and solve inequalities. We've done that with equations, so I'm going to review that. And then, of course, we're going to write and solve our inequalities. And 6.9b, we're going to represent our solution using a number line. So let's jump right into it. Here, a couple examples real quick of modeling inequalities. So our first one we're going to model says x plus 4 is less than or equal to 8. So what we're trying to do is trying to show what can we plug in here for x, add 4 to it, and our answer is less than 8. Now there's lots of numbers we can plug in there, but let's model what that looks like. I'm going to use a bar to represent x, and then I'm going to use I'll use circles, 4 circles, and I'm going to identify these as let's identify these as positive circles, because that's x plus 4. It's a little hard to do here on this video with my pen, but we have x plus 4, and of course it is less than 8. So on this side then I would need 8 positives. I'll do that like this. Okay, so we've modeled the original inequality. Now we need to model solving it. Again, our goal is to get the x, or this bar, by itself, so I need to remove these 4 positives. The way we remove 4 positives is to subtract 4, so we need 4 negatives. So what I'll do is I'll use a different color. We'll use circles as well, though, and these are going to be 4 negative circles. Now the positive and negatives will actually cancel each other out, but remember, what we do to the left side of an inequality or equation, we must do to the right side. Okay, so let's see what that looks like. So now I've kept this inequality balanced by putting 4 negatives on the left side and 4 negatives on the right side. The reason I did that is because a positive and a negative is called a zero pair. They cancel each other out, and all I have on the left side is my x. Okay, so I bring down my inequality sign, less than. On the right side, I'm going to cancel out, again, the zero pairs, a positive and a negative. But you'll notice that I'm left with these 4 positives. So now my solution says that our x has got to be less than or equal to 4. Now there's a lot of things that are less than or equal to 4, a lot of numbers, so we're going to represent that on a number line. So let me go to this side and do that real quick. Actually, let me go back here. So I'll draw a number line. I'm going to put a 4, and I'm going to put one number to the right, is 5, and I'm going to put one number to the left, which is 3. I'm going to go ahead and circle the 4 because that's what we're working with. Now, I am not going to shade it in because 4 is not included. I cannot put a 4 in here for x because 4 is not less than 4. It's equal to. So we'll not shade it in, but I will shade everything that is less than 4. Now I'm noticing on my number line here, this isn't going to have to be a -3. It could have been, but we're going to call that a 3 because 3 is less than 4. So you can see that everything to the left of 4 is what we would shade, and that would represent our solution. Okay, and then we have 3x is greater than 9. Now, this one's a little bit different, but let me go ahead and model this real quick. Okay, so now you can see that I've modeled it. I have 3 x's on the left side with these 3 bars. Okay, and then it says greater than 9, so I drew 9 positives. Now, I'm actually going to make a little change to this one. I'm going to make this a greater than or equal to problem, just for the sake of the lesson. So it doesn't change the problem much, but it will change the solution a little bit, and it will look different when we represent it on a number line, and that's why I did that. So we'll just call it 3x is greater than or equal to 9. Now, each one of these x's, we're going to divide up these 9 positives evenly amongst these 3 x's. So I will draw these lines to show you what that looks like. Each x then will be a value of 3. What we've done there is we've divided the left side by 3. 3 divided by 3 is 1, and then 9 divided by 3 is 3. So each x now is a value of 3, but since we're working with an inequality, it's x greater than or equal to 3. If you put in any number that's greater than 3, if you plug that in here for x and you multiply it times 3, your value or your result, the product, is going to be greater than or equal to 9. Since it's equal to, we could actually plug in the 3 because 3 times 3 is 9. Now let's draw that on a number line. Again, I'm going to put the 3 because that's what I'm working with. I'll put one number to the right, which is 4, and one to the left, which is 2. I'm going to circle the 3. I'm actually going to shade this one in because it includes, because of the equal sign. That means we shade that in. So, and then I'm going to shade everything that is greater than 3, and that would be to the right. So I'm going to shade this direction. Okay. So that's just a model for solving it. Let me just do this real quick, just in case you weren't sure understood what we did there. Since it's a multiplication problem, since the variable is being multiplied by 3, we did the inverse of multiplying, which is to divide by 3 on both sides. 3 divided by 3 is 1, so x is greater than or equal to, and 9 divided by 3 is 3. So that's where we got our answer, x greater than or equal to 3. Okay, let's move to a real-world situation. This says that Jill is shopping with a $50 gift card that she got for her birthday. She has already picked out a pair of jeans that cost $32.50. It wants you to write and solve an inequality to represent x, the most she can spend on a new shirt using the same gift card. Okay, so we need to set this up. We're going to start with x. This is how much she can spend on the new shirt. We don't know what it is. That's why we use a variable x. We're going to add to that what she has already spent. That's the $32.50. And we know that she has a $50 gift card, so she can either spend $50. When you add these two together, it can equal 50, or it would have to be less than 50 if she's going to use that gift card. Now, I guess this doesn't really take into account tax, but let's just talk about this in actual numbers before tax. So x plus $32.50 would have to be less than or equal to, and the amount of the gift card is $50. Okay. All right. Now, how do we solve this inequality? Well, this is addition. The inverse of addition is subtraction. We subtract $32.50 from the left side because we want to get x all by itself. $32.50 minus $32.50 is 0. So all we're left with is x on this side is less than or equal to, and don't forget the strategy that we use is that what we do to the left side of an inequality or an equation, we must do the exact same thing to the right side. So we're going to subtract $32.50 from the right side as well. And when we do that, we end up with $17.50. So that represents x, the most amount that she could spend on a sweater or on a shirt or something else to go with the jeans that she's already purchased for $32.50. $17.50 and $32.50 we total $50 gift card. Now again, I know there's tax involved, but we're just using this as an example. Okay, we would need to model this to show our solution because remember there's not just one answer because we're working with an inequality. So if we use our $17.50 as our solution, I'll put 20 to the right and I'll put 15 to the left. I always keep putting a negative sign there. I don't mean to do that. Just 15 to the left. Okay, so we're going to circle the $17.50. We're actually going to shade that in because she could spend the $17.50 before tax, of course. And then we're going to shade everything that is less than that amount. Because if she only spent $10 on a shirt, the gift card would cover it. Okay? All right, last example. This says an isosceles triangle is obtuse if 2x is less than 90. Now that might sound a little confusing to you, but really what we're working with here is this inequality. Let me show you what an isosceles triangle is. This is an isosceles triangle. Basically, these two measurements are the same. Well, so this value would be x. Those two values would be x. They would be the same because it's an isosceles triangle. And then this value here would be because it's an obtuse isosceles triangle, then this measurement is going to be actually greater than 90. So what this is saying is when we add these two together, 2x, those two values need to be less than 90 when we add them up. So this is a multiplication problem here. We're multiplying 2 times our variable x. Well, the way that we solve these inequalities equations is we do the inverse operation, and the inverse of multiplication is division. So we're going to divide both sides by 2. And 2 divided by 2 is 1. So we have 1x is less than, and then when we divide 90 divided by 2, we get 45. So as long as these x's are less than 45 degrees, then this would make this greater than 90 degrees, making an obtuse isosceles triangle. Again, let's go ahead and put that on our number line to identify the solution or the mini solutions. So we'll do 50 to the right, we'll do 40 to the left. The number that we're working with is 45. And it says it actually has to be less than 45. It can't equal 45. So we would shade everything to the left and we would keep this circle open. Okay, that's a little review of writing and solving and modeling inequalities.